Why didn't you tell me earlier?
I thought you
Yeah.
were just asking generally.
Oh, no, 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 no. Okay. So, yeah. Okay. Okay. Yeah. So, I wrote, yeah. So, this was my potential, right? Let me say that this is my potential. Okay. So, electric field would only have the x component, right? So, I will have d by dx of this. So, this would be only ex, right? Which would be minus dv
Yes,
by dx, right? So then if I calculate this, so Ex would be this. So E vector would be minus 4xi. Is this clear to you?
yes, sir.
Now let's say that my potential is this, minus 2xy, right? So I will
Yes, sir.
have two component, which is x component of electric field and y component of electric, right? So x
Yes, sir.
component would be minus dv by dx, y component would be minus dv by dy, right?
Yes, sir.
So if I calculate x component, so this would be Ex, which is minus and minus of 2xy. So minus minus cancel and I have 2 and differentiation of xy, right? But this is with respect to x, so y is taken outside because this is a partial differentiation, right? In partial differentiation, all the variable are treated as constants. So only x is the variable one. Rest all are constants. So y is constant, so it is taken outside. And dx by dx is 1. So ex is how much? Only 2y. Right.
Yes, sir.
Similarly, I can calculate y component of electric field as minus dv by dy. Right. So potential is minus 2xy again. Then minus of minus is positive and 2 is taken outside. Differentiation of xy. But this is with respect to what? Y, right? So I will take x outside and I will only take the differentiation of y. So ey would be, so this cancel and I have 2x. So ey is 2x, right? Ey is 2x, ex is 2y. Understood? Yes, Tarif, understood.
Yes, sir. Understood.
So my electric field will have two components. One would be x component and the other would be y component, right?
Yes, sir.
This is my electric field. 2y,
Yes, sir.
ex is 2y, ey is 2x. Now can you tell me what would be the magnitude of this vector?
Uh, 4xy.
Yeah, root of,
Yeah.
right, this would be my
Yes, sir.
electric field. So let's say that this is my A vector. So what is the magnitude of A vector? Root of 2 square plus 4 square, right?
Yes, sir.
So similarly, I have this magnitude. So this is 4y square and 4x square. So 4 is taken outside and I have 2 of y square plus x square. This is my magnitude of electric field, right? So,
Yes, sir.
so for the potential of this kind, for the potential of this kind, this is my electric field. Is this clear to clear? Yes, sorry, clear.
Yes, sir. Clear.
So please note down this part, and whenever the rest of the people come, then we will do the question that we were doing.
Okay, sir.
And if you have any doubt, please ask. So if this is not clear, then I will explain it again. If you want me to explain it again, is this clear? Yes,
Yes, sir. Clear.
yeah. Whenever the form of the potential is given, So you can always calculate the electric field. Similarly, whenever the electric field is given, so you can always calculate the potential, right? So all these things are related. Okay, so whenever you want me to scroll down the screen, you tell me. And where are the rest of it? Yes, do you want me to scroll down the screen? Yes, noted, Satari.
Yes, sir, noted.
Okay, and this part, so
Yes, sir.
after, oh, you have also noted this part. Okay, so let me talk to the Learnivio team, right? We were doing this question. So we will discuss this question when availability or rest of the thing. So let us wait. Right. And when will your school reopen?
Uh, August 28th.
28th or 20th?
Yes, sir.
So it's been close. We have 20 days and okay, let's see how much we can. So in your CBSE class, how much they have completed? Yeah. So in your CBSE portion, how much is
And school,
no, not in school. In your CBSE class.
yes, we done till the fourth chapter.
Also, you have completed the fourth chapter also.
About to seven, the last topic.
Oh, last complete. So galvanometer, moving coil galvanometer.
Yes, sir, yeah, I think.
Yeah. Let's finish the second chapter and then start the current. So today I will talk about potential energy, right? And potential energy of dipole, and then I will talk about potential energy in external electric field, and then I will talk about the capacitor. Okay, let me talk to the Learnivio team and let's see the rest of it. Okay, so they will come, right? Meanwhile, we should start. So this is the form of the potential, okay? Tarif, and you please calculate what would be the magnitude of electric field, right? So please calculate the magnitude of the electric field. You have this form of the potential. Yes, do you note down this question, Tarif?
Okay, sir.
Yeah, please calculate and tell. X square, y cube, and z square. Very,
Like we calculated EY and EX and EY, right? Should I calculate EZ?
yeah, yeah. So calculate
Yes.
all the part 3x square, y cube, and z square. What's this question? 3x square, y cube, and z square. Yeah. Calculate all the electric field. Okay. And tell me that what is the magnitude of the electric. This is the question. And whenever you get any answer, please tell. Because nobody is here, so yeah, you practice all the question, and I will help.
Sir, I think I got an answer.
Yeah.
Yes,
So
EZ will be minus 6x square y cube Z.
so Ez is minus 6x square y cube
Yeah.
z, and Ex is how much?
EX is yeah, minus 6x y cube Z square.
And then how much is Ey?
Yes, minus 9x square y square Z square.
So now we have all the
Oh,
components, right?
yes, sir.
Now we have all the components, and then we can calculate the electric. So electric field is minus 6xy cube z square plus or which is I hat, and minus again 9x square y square z square, and j hat, and minus 6x square y cube z k hat. Right. Yes. So this is the electric, right? Yeah, Shavez. Yes, hello Shavez. Assalamu alaikum. Hello Shavez, can you hear?
Walaikum Assalam.
Yeah, so we just started, right? So in the previous class, we were calculating the electric field due to some potential, right? So the some form of potential was given, and we were calculating the electric. So we calculated all the x, y, and z component of the electric field, right? Using these relations,
Yes, sir.
and then we found out the electric field is. So the magnitude of this electric field would be how much? This would be 6 x y cube z square whole square plus 9x square y square z square, right, and whole square, and plus 6x square y cube z, and then whole square. So what is the common terms here? So x, y square, and z. So x, y square, and z is common, so we take it outside, right? And also 3 is common, so 3 we take outside. So this would be 2x, and x we have taken outside. So this is y and z whole square, plus this is 3, and this is x, and y square we have taken outside, xz whole square, plus and 2, and x, and y whole square. So this is our electric field, 3xy square z, and root of 4y square z square plus 9x square z square, and plus 4x square y square. This is the magnitude of electric. Right? Is this clear to you guys?
Yes, sir.
Okay, so please note it down, and then we'll start the next topic. Please note it down. And if you guys have any questions, you can ask. Whenever you guys have noted it down, ask.
Sir,
Noted.
sir, previous we did potential difference of long line charge, right?
Yeah, potential difference of
Long line charge.
line charge. Yeah, potential difference of line charge. Yeah. So after potential difference of line charge, we came to this concept.
Okay.
So yeah, electric field as the gradient of potential. So we have calculated the potential of all the symmetric objects, right?
So can I scroll up?
Yeah,
Can you scroll up?
yeah. Scroll up or down.
Up.
Okay, where? This was the equation that we were doing, right? This one. This was the question that we were doing in the previous class, and the time got over. So, and then I
Yes,
started.
sir.
Yeah. Okay, noted up to this point.
Yes, sir.
Okay, so now let us talk about the potential. Right, we have calculated all the potential. Now let us talk about the potential. So what is a potential? Right. Okay. Yeah. So potential energy rises due to the conservative interaction between the charges, right? So this arises and this is equal to the work done to make a system, right? And you guys have already derived that, let's say we have 2 point. So potential energy of 2 point charges, right? At the separation between them is R. And
Sir, potential energy for one point charge is zero, right?
yeah,
Potential energy for one point charge is zero, right?
right. Because we don't need any, we don't do any work to make a point charge, right? So you only can make 2 point charges, right, to make a system. So system consists of 2 point charges, right? 1 point charge doesn't make a, right? Yeah. So if the charge is, if one charge is in the external electric field, so if it is in the, if it is isolated, right? So no work is required to bring that charge, or no work is required to make that system, right? If it is a single charge. But if the single charge is in the presence of some electric field, then we can talk about the potential energy. Is that clear? Yeah. Is this clear? Yes, Shavi.
It's clear, sir.
Yeah. Because potential energy is what? It arises due to the interaction between the charges, right? Due to the interaction of charge with some electrical field around, right? But if you have a single charge and you don't have anything else around, so how can this charge interact with other things, right? So then the potential energy, right? You can think it that way also, right? And the interaction can only happen if you have two things, right? Either two charges or one charge in the external electric field. Okay. So this is how we define the potential energy of two charges, right? And let's say that, okay, so do you guys have mathematics in your, did you guys had mathematics in your 11th class?
Yes, sir.
And yeah, did you learn about permutation and combinations?
Yes. I have the device.
Oh, so if let's say that I have n charges, right? I have n charges and I have to select two charges at a time. So how many combination would be there? I have n charges. Let's say in a box, I have n charges,
LCR.
and I want to take two charges at a time. So how many combination would be there? How many interaction can be there? Okay, we'll talk about this later, but let me write. Okay, so if we have potential energy due to multiple charges, right? Or let's say n charges. This is defined as k and 1 by 2 summation I equal to 1 to n, and then this is I j equal to 1 to n, and this is qi qj divided by Rij, right? And where your I not equal to J. So this is the potential due to N charge, right? So if I have, let's say if I have three charges, okay, let's say this is Q1, this is Q2, this is Q, and this is R12, this is R23, and this is R1, right? So what would be the potential in that? And remember, this is the work done to make this system, right? So potential energy, let's say I take this charge. So this is interacting with this one and this one, right? So let's write the interaction. So K Q1 Q3 by R1 plus K Q1 Q2 by R2, right? So I took the interaction of Q1 charge. Now let's say I take the interaction of this charge, right? So this is interacting with this one. This we have considered. So only thing which is left is this one, right? So then this would be how much? This would be K Q2 Q3 by R2. So this is the result of these situations, right? Okay, so can we have another kind of interaction and any other possibility? Yes. Can we have any other possibility for these three charges? Can we have any other possibility? Chavez and Tariq, can we have any other possibility?
No,
No, sir.
Right. So how many interactions were there? This is three,
3.
right? And how many charges were there? Three. So if we have n charges and we have to pick two, so I can represent this by n because you already know you have known this combination, so that's why I'm writing NC2. So can you guys tell me what is NCR? What is NCR? You guys have read
Yes,
about
sir.
this,
Combinations.
yeah, combination, right? So what is
Yes, sir.
NCR?
number of combination of R things.
Yeah, so NCR meaning that in the total of n number of possibility, I am taking two at a time, R at a time, right? So R at a time, and this is defined by n factorial, R factorial, n minus R factorial. So now do you guys remember this? Do you guys remember this?
Yes, sir.
So can you guys calculate? So let's take the example of this case. So I have three charges and I have to pick two. So can you guys tell me how many possibilities would be there? How many possibilities?
So can you scroll up?
Yeah. So I have three charges and I want to pick two charges. Interaction, which means I want to pick two charges. So what would be the possibility? N is how much?
Hmm.
N is
3.
2,
3 and R is how much?
2.
2. So 3C2 possibility, right? So this would be 3 factorial divided by 2 factorial, 3 minus 2 factorial. So this would be 3 into 2 factorial divided by 2 factorial into 1 factorial. 1 factorial is 1, 2 factorial, 2 factorial cancel. So how many possibilities? 3. So did I get 3 possibilities? Yes. Understood, guys?
Yes, sir.
Okay, so please note down this part and then I will talk about, yeah, so please note down this part and then I will talk about some other. Whenever you guys want me to scroll down the screen, right? Then you guys please tell.
Sir, what is N?
Where? Where?
NC2 here in NC2, what is the N?
N is the total number of the system or total number of things that I have, right? N is,
Charges.
yeah, in this case, this is total number of charge, right? In our case, for our purpose, N is total number of charge and R is how many charges we are taking at a time. So for interaction, how many charge we take? For
Two
interaction,
charges.
2 charges, right? So the combination would always be NC. So yeah, you guys please note down and then I will ask one question. So whenever you guys want me to scroll down the screen, guys. So remember, arrangement is permutation, selection is combination. So that is how I remember permutation and combination. Yes, sir. Should I scroll down the screen, guys? Noted, guys. Yes, Chavez and Tarif. Yes, guys. Noted. Am I audible?
Yes, sir, noted.
Tarif, noted. Yeah, so you guys write that total number of interaction is NC2, right? Where N is the total number of charges. Okay, and NCR is N factorial divided by R factorial N minus R. So if I ask you that how many interactions I can have in this situation, right? So let's say this is plus E minus E and this is 2E minus 2. So how many interactions can I have? without doing the calculation. You guys tell me how many interactions will I have? Yes, Chavez and Tarif. How many interactions? Tarif and Chavez. I have how many charges?
Four.
Yeah, your voice is not audible, guys. Maybe there is a problem with your mic. So Tarif and Chavez, how many charges do I have? You can also write it in the chat box.
Four charges.
Four charges, right? So I have four charges and the total number of interactions would be 4C. Right. So what is how many interaction would be there? Calculate and tell. Calculate and tell me that. Yeah.
6 interactions.
Six. So Chavez got six interactions. Tarif, what is your answer? Yes. Tarif, what did you get?
Can you tell again?
Yeah, so we have four number of charges, right? So how many interactions would be
Yes,
there?
sir.
How many interactions would be there? Chavez is saying six.
8.
You are saying eight.
Yes, sir. Plus 4 into 2.
Yeah, so 4C2, not 4 into 2. So 4C2 would
Yes, sir.
be
4 seat.
4 factorial divided by 2 factorial and 4 minus 2 factorial. So 4 factorial is how much? 4 into 3 into 2 factorial. And 2 factorial is 2 and then this is 2 factorial. So 2 factorial cancel, 2 cancel and I have 6. Understood? Yes, Chavez, you are correct. Tarif, understood.
Yes, sir.
Okay, so similarly, we can calculate any number of, let's say for uh, these kind of, right, so I have this one. At least I can calculate number of interaction. Okay, so always remember that number of interaction is NC2. Okay, so we can also see from here that let's say if I pick this one, so this is the interaction, this one and this one. So from this I have 3 and from this I have this one 1 and 2. So this is 2 and what is remaining? So remaining one is this one, right? So 1. So 3 plus 2 plus 1 which is 6. Right, so this question you have already done in your class, right?
Yes, sir.
Okay, so I will skip this question and let us do a problem which is a little bit different. So three charges, three charges are placed at the vertices of the triangle or equilateral triangle. Equilateral triangle, let's say of side A. Okay. So first question is that calculate the potential or the charges which are has magnitude q. So calculate the potential energy or work done to make the system. Right. So we have three charges. Very simple question. We have three charges. So this is Q, this is Q, and this is Q. And this is A, this is A, this is. So what is the work done to make the system, which is the potential energy? So this would be how much? How much would be the potential energy? Yes,
3 kq square by
Chavez,
r.
3 kq square by
Sorry, by a.
by right. So this would be the potential energy of this system, right? Is that clear, guys? Now, what I want to do is that I want to shrink this configuration and I want to make a system, right? So I want to shrink this system and bring the charge at, this is not visible. So I want to bring this charge to half the distance. This is Q and this is A by 2, this is A by 2, this is A by 2, right? So I shrinked the charges, the configuration and put it to A by 2 distance. So the question is what is the work done to bring the charges to A by 2 distance, right? So what is from work energy theorem? What is the work done? Yeah, what is the work done?
Sum of all external and internal,
Yeah, so work done is,
conservative and non-conservative forces.
yeah, so work done by conservative. We are talking about the conservative force, right? So this is uh, potential energy final minus change in potential energy, right? This is the work done, right? So this would be how much? So what is the final potential energy? What is the final potential energy, guys? Yes. Tarif and Chavez, what is the final potential energy? Yes, guys. Yeah. So let me draw the diagram. So I have this charge, this charge, this charge, and distance is V by 2. So what would be
So
the
it
final
is
potential?
6 kq square by a.
Yeah. So 3 kq square by A by 2, which is 6 kq square by. So this is my final potential energy, right, Tadip? And
Yes, sir.
initial potential energy we already calculated. So this is 3 kq square by. So work done in bringing the charge from the bigger configuration to smaller configuration, this would be simply 6kq square by A minus 3kq square by, which is 3kq square by. Clear? Is
Yes,
this
sir.
okay? So, did you guys do this question in your CBSE class?
No, sir, we only finished basic questions.
Yeah. So, okay. So, please note down this problem. And whenever you guys want me to scroll down the screen, guys, tell.
Scroll down.
Yes, noted, guys.
Yes, sir.
So now the next from the similar question. So now what we do is that we have this configuration, right? This is Q, this is Q, this is Q, and this is A. And what we do is that we release these charges, right? So we release these charges, and then it comes to this part. So now it has come to this 2A distance, right? So now it has come to this 2A distance. So the question is that what is the velocity of, what is the velocity of these three charges at 2A distance, right? So what we did was that these were the initial configuration, right? And what we did is that we just released these three charges in separate direction. So this has come to this point, 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 and this has come to this point. So it is moving. But we want to calculate the speed of these three charges at these positions. So is this question clear to you? Is this question clear, guys?
Yes, sir.
So what we can do in here? What should we apply here? What should we apply? we already know about the potential energy at these 3 points. We already know about the potential energy of these.
Kinetic energy.
Yeah, so you are thinking very correctly. So we know about the potential energy, right? And at two-way point, you have the potential energy plus kinetic energy. So this potential energy is changed to some potential energy and kinetic energy, right? So from energy conservation, we can calculate the kinetic energy at these points. Is that clear to you, guys? Clear? Is this clear?
Yes, sir.
So from
So like at 2A, at Q 2A point, we're calculating the velocity.
yeah, at two-way point, so we know that E initial, this is equal to E final from energy conservation, right?
Yes, sir.
So at two-way point, at a point, initially they were not moving, right? They were at rest. So we had only potential energy, right? But at this
Yes.
point, we have some potential energy as well as the kinetic energy. So we will write that. So we will have PE initial plus KE initial. This is equal to PE final plus KE final, right? So we have potential energy which is 3kq square by A, and this is 0. And potential energy final is how much? 3kq square by how much? Yes. What is the final potential energy? 3kq
6.
square by 2a,
No, no, sorry. 2A's.
right?
Yes.
And how many? So for one charge, what would be kinetic energy for one charge?
Half UV
Half
square.
mv square, right? And all these three charges are similar. So they will all have the same velocity. For three charges, this would be 3 into half mv square, right?
Yes.
So what would be, so the, this would be how much? This is 3kq square by A minus 3kq square by 2k. So this is 3 by 2 mv square, right? So then we can calculate, this is 3 and this is 3 by 2. So this would be 3 by 2, right? Kq square by A. And this is 3 by 2 mv square, right? So 3 by 2, 3 by 2 cancels, and we have v square, which is what? Kq square
So
by
you didn't
A.
take LCM here.
Yeah,
You didn't take LCM.
yeah, I directly just calculated. So this is 3 minus 3 by 2. So this is 6 minus 3 by 2, which is 3 by 2, right? So 3 by 2.
Yes.
Yeah. So 3 by 2, 3 by 2 cancels and m goes in the denominator. So this, so velocity would be kq square by am. This is the velocity. Is this clear to you guys?
Yes.
Okay, so please note it down. And yeah, please note down this problem. And whenever you guys want me to scroll down the screen, please tell. Yes, whenever you guys want me to scroll down this. Noted up to this point, guys.
Yes.
Yes, so please note it down. And whenever you guys have completed, please tell.
Yes.
Done. Tarif, noted.
The last one.
Okay, please note it.
Yes, sir. Done.
Okay, so we now we have calculated the interaction between the charges. So we saw the multiple charges and two charges. Now, what happens when we have right when we have external field? So potential energy in uniform electric field. Right. So we have some electric field, right? And we have put some charge. Okay. So at this point, this is some electric field, right? So at this point, there would be some potential, right? So let's say this is VR. Okay. So the work done to make the system would be how much? Q. And from, so we are, this is from, let's say, infinity to, let's say, some fixed point, right? So this, let's say this is some R. So this would be VR minus V infinity. So we know that this V infinity is zero, so this would be simply Q, right? R. So this is the potential. Okay. Whenever we have a charge which is present in the in some electric field, then this would be the potential energy of that single charge. Right. Is this clear to
Sir,
you? Yeah.
work done on this charge is stored as potential energy.
Yeah.
Work done on this charge is stored as potential energy.
Yeah. So work done in making the system. So we are bringing this charge from infinity to this point. Right.
Yes, sir.
So that would be equal to the potential. Okay. But in the earlier case, when there was no electric field was around, right? And this charge was a load. So to bring this charge from infinity to, let's say, this point, so this was V infinity, and that, let's say, this is VR, right? So what was the work done? And that was Q VR minus V infinity. So this was also 0 and this is also 0, right? Because there is no potential. There is no source charge around, so there is no potential here, right? So this is 0, this is 0, so this was 0. So potential energy was 0 for single charge, right? But now for the case of the presence of the electric field, we are doing some work in bringing a charge from infinity to this point, right? So this will be the potential energy. Is this clear, guys? Is this clear? So this is the potential energy of single charge for the case of single charge. Clear, guys?
Yes, sir.
Sorry, okay. So now let's say we have two charges, right?
Sir, I didn't forget.
Oh, you didn't note it down. So okay, so I will give you guys some time, but okay, if you want to note it down, please note it down. Yeah, so this was the first topic that I covered, right? Work done,
Yes,
right? So okay. Noted, Tarif and Chavez.
yes,
Okay.
sir.
Okay, so now we have two charges, right? So we have two charges and they are present in the electric. So I will directly write the formula you guys have already derived that. So this is Q1 and the potential is V1 and this is Q2 and the potential is V2, right? And this is the electric. So the potential energy is simply Q1 V1 plus Q2 V2 and the interaction between these two charges. So K Q1 Q2 by, let's say this distance is R, so this is R. Clear, guys?
You can just explain once again.
Yeah. Yes. What do you say, Chavez?
Sir, can just repeat once again.
Yeah. So we have two charges, right? They are placed. They are placed in this electric field, right? So what I do is that I have two charges, Q1, Q2. I bring this Q1 charge from infinity to this point, right? So work done would be how much? This would be Q1 V1. Similarly, I bring this charge from here to there. So work done would be how much? Q2 V2. But there would also be these interaction between Q1 and Q2. So this would be the total work done in making the system. So one would be Q1 V1, then Q2 V2, and then this interaction term. So this would
Yes,
be
sir.
this would be the potential energy in bringing these two charges at these two points. Understood? Clear, Shavi?
Yes, sir.
Okay, so let us do one problem and then it will be clear.
Sir, I have to write.
Oh, you have to write. Okay. Yeah, so just forget about this part, just write that. Noted, guys.
Yes, sir, noted.
Yes, sir.
Okay, so this question you have already done, Junior, but let me repeat it. So two charges uh, of magnitude, let's say 2 millicoulomb and minus 2 millicoulomb are separated by 40 centimeters, right? Distance and placed at let's say minus 700 and 700 respectively, right? In the presence of electric field which is 1 over, let's say, r square, right? Or let me write as a over r square. Okay, then find the potential energy of the system where a is 10 to the power minus. Okay, so this is the question. Is this clear to you guys? Yeah. So let me draw the diagram. Diagram is important. So we have this electric field, right, which is varying like. So you see that this is a non-uniform electric field, right? So this is varying like A by R square. Okay. And in this electric
Sir,
field,
what is it?
yeah, what is A? A is a constant whose value is 10 to the power minus.
R square is variable.
Yeah, R square is there, right? R square is variable. And we have two charges placed at, let's say this is 2 millicoulomb, which is placed at minus 700. And then we have this is 14 centimeter, right? And then this one, which is minus 2 millicoulomb. And this is at 700. Okay. So then we have to calculate that what is the potential energy, right? So to calculate the potential energy, we know that this would be Q1 V1 plus Q2 V2 and plus K Q1 Q2 by R. Right, guys?
Yes, sir.
So we have to calculate, we know Q1, Q2 and R we know. But we have to calculate this V1 and V2. So we need to calculate V1 and we need to calculate right. What do we know about this electric field? So what is the relation between the potential and electric field?
Electric field is equal to derivative of
Yeah, this is E dot dr, right, guys? Did you say this one, Chavez?
said about behavior.
You said this one.
Yes, yes, yes.
So you see that electric field is given, but we want to calculate the potential. So we will use this one, right?
Yes, sir.
So let us calculate. So this would be how much? This would be, and from infinity to let's say R point. So this would be how much? This would be A is A by R squared. Yeah. So A is taken outside. And what is the integral of 1 over R square? What is the integral of 1 over r square? Or let me write in this way, r minus 2 here. What is the integral? What is the integral of xn dx? Yes, guys, what is the integral of xn dx? Because forgot the integration. So this is xn plus 1 divided by n plus 1, right?
Yes, sir.
So r minus 2, this would be r minus 2 plus 1 divided by minus 2 plus 1. So this is r minus 1 divided by minus 1, which means that minus 1 over r. So minus 1 over r. So this would be minus minus cancels and E over r. This is the potential, right? So we want to calculate the potential at minus 700. So what is the magnitude of minus 770? Right, vector is r is minus 7i plus 0j plus 0j. So magnitude is root of 7 square plus 0 plus 0, which is 7. Right. So V1 is A by 7. V2 is also A by 7. Is this clear to you guys?
Yes, sir.
So now we know V1 and V2 and we have Q1 and Q. So we can calculate. So Q1 is 2 millicoulomb and Q2 is minus 2 millicoulomb. And how much is the distance R? This is 14 centimeters. So U is Q1 V1 plus Q2 V2 and plus K Q1 Q2 by R. So Q1 is 2 into milli is minus 3, right? And V1 is A by 7. And this is minus of 2 into 10 to the power minus 3 A by 7 and plus of K, and this is 2 into 10 to the power minus 3 and minus 2 into 10 to the power minus 3 divided by 14 into 10 to the power minus 2. Right. So this is same but minus. So this one cancels. So we will get minus of k into 4 into 10 to the power minus 3 into 10 to the power minus 3 divided by 14 into 10 to the power minus 2. So this is minus 9 into 10 to the power 9 and 4 into 10 to the power minus 6 and this is 14 into 10 to the power minus 2. So 9 plus 2, 11 minus 6, 5. Right, so this is 2, this is 7. So minus 18 by 7 into 10 to the power 5. And so this is the potential. Any doubt, guys? Any doubt?
No, sir.
And what does this negative sign signifies? You must have learned in your CBSE class. What does this negative sign signify?
Finished by the system.
This is a what? This is what kind of system? Yes, yes, Shavez.
It's by the system. It's done by the system.
What system? I cannot hear you properly.
It is done by the system. Work.
Uh, Okay, are you saying bounded system? Yeah. Are you saying bounded system?
No, no, sir.
Yeah. So this minus sign signifies that this is minus sign signifies bounded system, right? So if this is negative, which means that this is bounded system, right? And we have to give some energy to break that system, right? And if that is positive, so which means that it will release some energy. So minus sign signifies bounded and positive sign signifies unbounded. Understood, guys?
Yes.
Okay, so please note it down from here. And if you guys have any questions, so you can ask. And whenever you guys want me to scroll down the screen, guys. Should I scroll down the screen, guys?
Yes, sir.
One, I wanted to complete the potential energy due to dipole also, but yeah, we'll do it in the next class.
Yes, sir.
Done. This part also done. Yes, this is also noted.
No,
Okay. Whenever you guys have completed these steps,